Good morning, everybody. Good morning. All right. So this is day 2. Time is it now? 10 past 9. 10 past 10, sorry. And 9 past 10, something like that. So I want to see if we can clear 2 topics today. As you can see on the screen, we are doing number theory and computation. And basically, remember, I went through the syllabus yesterday. These are the topics that we have to do for the paper 1. We looked at it yesterday. We did the sets yesterday, and we also did the consumer arithmetic yesterday. All right, so today now, we're going to just go back and see if we can clear 2 of these topics. If we can get up the 3 topics today, that will be good. All right, but we don't want to rush it. We want to do it in a quality way, because we still have this week, next weekend, and basically all of the week after, because it's basically next week Friday, all right? But the sooner we can get through this and then allow you guys to practice what we're going through now, the better. All right. So let's see if we can clear 2 topics today. So I say we finished this one already. And no, not there. We did that. We do those 2. So today now I'm going to start with that one and then we'll work our way down. All right. So hopefully we can do these 3 today. If not those 3, at least those 2. All right, so we're talking about 6 questions topic and another 6 questions topic. All right, the next big topics are these topics down here, which are 8 questions each. All right, so who knows? Maybe I might just jump to one of them, but it no matter. We're gonna get through all of them. So we want to do the first one, which is the reason I did the sets yesterday first, because sets is the topic that we would not have done in preparation for paper 2. Everything else would have gone except set. Sets is the only topic that is not on paper 2, but it's on paper 1. So the paper 2 syllabus over here, you're not gonna see sets on it. All right, over here. That's paper 2. All right, so let's go. So just basically working through some of the questions. Somebody might ask you to do it first, just to keep you engaged and work through, all right? This first question says, what is the value of the digit 2 in this number? So here's a digit 2. There's 2 places after the decimal point. And so that's 2 divided by 100. Or put another way, the value of that 2 is 0.02, which is the same as 2 over 100. That is it. Simple as that. All right? This one. What percentage of 50 is 10? What percentage of 50 is 10? That's 20%, right? Let's say though, you can say, okay, what percentage, working like an equation, you don't know that. What over 100 times 50 is equal to 10? That's what you're solving. What percent, x over 100 of 50 is equal to 10? All right, so it becomes 20. This cancels into this 2 times the 2 multiply up, you get 20. Anyway, you want to look at it, this 20. The answer is 20%. I remember, you know, the answers are on the paper, you know. So if you don't know to work it out, you just all right. 5% of 50 is what? 20% of 50 is what? I could work it out. But so, okay, you have 50, right? 10%. 10% is 5. 10% is equivalent to 5. But 10% of 50 is 5. So to reach 10, it has to be 20%. 20%, therefore, is the 10. So the answer is 20%. Now it doesn't matter. That is, when people put the 10 over 50 times 100. All right. Next one. This in standard notation is equal to what? Now, once you see this is a very small number, because it's the first non-zero digit starts 2 places after the decimal point. So it is a very small number. So you know the ball is going to be negative. The ball is going to be negative when there's a very small number. And the decimal point has to be here. Okay, you must have 1 non-zero digit before the decimal point. So that is actually 2 times 10 to the minus 2. Well, actually, you have to write out the whole number, right? So it's 2.0 something. It is 2.086 times 10 to the minus 2. But that's just doing it quickly. If you want to use a calculation method to do it, what you can do is, okay, how do I get the decimal point here it is supposed to be? Because decimal point here, I would have to multiply by 10 squared. I have to multiply by 10 squared to get the decimal point where I need it to be in standard form. And that will move the decimal point for us and put it where it is. To balance back out that multiplication by 10 squared, multiply by 10 to the negative 2. Because 10 squared times 10 to the negative 2, they balance out each other. But inside the bracket here, we'll move the decimal point for us and put it at 2.086. And then this now is the 10 to the minus 2. And so the answer is this one. I'm careful and don't mark this one. That one is wrong. The answer is this one down here. All right. We must have one non-zero digit before decimal point in standard form. Same question down here, so or a similar question, but see same digits, but that number is a big, the number in the hundreds. So you notice that the power now is going to be positive. And it's going to be 10 squared, because 10 squared is in the hundred, right? So it's going to be 2.0806 times 10 squared. But how would you work it out? Again, you want the decimal point right here. So to get the decimal point, they'll move it 2 places to the left by multiplying by 10 to the minus 2. 10 to the minus 2 will move it 2 places to the left. That's what will move it for us. Cancel out that multiplication of 10 to the minus 2 and multiply that result by 10 squared. And when this moves the decimal point and put it where we want it, it becomes 2.0806. You're left with that 10 squared. And so that's where you can actually examine that. And this time the answer is A. So you see the discount put by the same answers as over here. That's why you have to be careful. The difference. Because some persons might memorize the answers, I remember I memorized that the answer for this question is this. And see the same digits and not understanding, think that this is the answer again. It's wrong. So you cannot go sorting answers. You have to know what you're doing. Yeah, man. You cannot go depending on sorting answers. Next question down here. It says in a class, ratio of the number of pupils to teachers is 20 to 1. So pupils to teachers 20 to 1. And the question says there are 840 pupils. How many teachers are there? So my method of doing ratio is to bring the ratio up to match the actual information. So I want the 20 side representing the pupils to come up to be 840, the 840 pupils. So the question is, what do I multiply this by for it to become 840? Well, this 0 is already there. So it's really, what do I multiply the 2 by for it to become 84? But the 0 is already there, right? What do I multiply the 2 by for it to become 84 so that the result is 840? You're clearly going to be multiplying by 42, as simple as that. Going to be multiplying by 42. And that will make the pupil side from 840 that you want it to be, that it actually is. And then this side becomes 42. And so the answer is this 42. To me, that's the easy way to do it. Yeah. Understand that? Mr. Todd, good. Bring the ratio up to reflect what it actually is. And then you'll have actual numbers. But ratio can be multiplied or divided by any constant value or any constant unit of measure. All right. Next question. This one says a bag of apples can be shared equally among 6, 10, or 15 children. The minimum number of apples is likely to be in the bag is. So you're looking for the LCM of these numbers, the lowest common multiple of these numbers. And when you calculate the lowest common multiple, you always multiply the larger one first and see the other two are factors of that larger multiple. All right. So you have 6, 10, 15. Looking for the LCM, lowest common multiple. Multiply this one first. Do this one first. This one first value is 30. But these now are factors of 30. Right? These are factors of 30. This can be multiplied up by 30 by multiplying by 3. It can multiply up to 30 by multiplying by 5. The 30 is our lowest common multiple, and that is the answer. LCM. Same question is asked here. What is the least number of apples that can be shared equal between 6, 10, and 15? Same thing. So the answer for this one is the same. The same question on a different paper, written the same, written a different paper. It's actually the same question. Again, I need the LCM. All right? I'm going to do some work, you know. So, but no, let me get some paper. When I go to some work. All right, so we did a question like this a while ago here. What percentage of 50 is 10? So do this one for me while I go for the paper and tell what the mark, what the answer is. This one. What percentage of 40 is 8? It's the same answer. Let's change the number. What's the answer? There. You guys are doing this over work. B, yeah. 20%. Come on, let's start with one. I know, put down the tables. So I know what percent is 40. Can do something like this, quick and fast. You can say, okay, 10% is 4. 10% of 40 is 4. What percent of 40 becomes 8 has to be 20. Multiply this by 2. Therefore, 20% is 8. What is it? 20%. We could do it over here a while ago with this one. Right? Like that. All right, next question. So this one tells us that this product is equal to that number, and now asking us what this product is. Now there are multiple ways to do this. I'm telling the exam, the answers are on the paper. You don't have to work out everything. You just have to be smart about what you do to get the answer. Now in real terms, this is almost 0.5. Got it? And this is almost 24, don't it? That would be almost 12. Closest number to 12 in these answers is this one. That must be the answer. But this is too far from 12. These are just too far from 12. Cannot be the answer. So the answer must be A. But that's not. Sometimes we just have to be smart. But another way to look at it is to count the number of places the decimal points move from here to here. And then apply that same number of moves to this to get what the answer is down here. Let's look at it. So from this to this, the decimal point was moved one place to the left to go from this to this, don't it? And to go from this to this, it was moved 2 places to the left. That's a -1 and a -2 move. Total of -3. So to get answer for this one, I'm going to have to move this 3 places to the left. 1, 2, 3. That is why the decimal point is here in the answer, which is the first one. Yes, sir. But after I just counted the movement because it's the same value, same digit in the multiplication. So there's a decimal point we're going to move somewhere else. Simple as that. All right. Using the distributive property. Now, the distributive property has to do with factorization and also expansion of factorization bracket. Is that factorizing or expanding? Factorization bracket. That's what the distributive law is about. And they say, what is this equal to? So basically, you can look down and see which one it's equal to, you know. And in this case, the common factor is 49. You can see it. It should be 49 into 17 plus 3. 17 plus 3. So that's 49 times 20, which is the first one. 49 times 70. All right, another way to look at it, just say this is 1749 plus 349 equals 2049. But then we look at it, that I mean, this is easy stuff. This one now is a similar question. We write an expanded form of this expression. Looking at the answer down here, you see that the 99 comes back unchanged. So they have done that, broken up that 101. Because the expanded form is what I have done here is like writing it in the expanded form. So this again, if we write it in the expanded form, it will be 99 times, and then this 101 is 100 plus 1. So multiply the 99 times the 100 plus 99 times 1. Where is that one? The last one. That is it. That's the answer right there. All right, questions are pretty easy so far. Come this one for me. What is the next term in this sequence? There's a sequence. I'll pick up the pattern and see what value must go on here. Do that one for me quickly. Huh? 46 again. What is? Huh? What you get? 46 though? I get 46. So let's look at the pattern. So from this to this is a plus 5, right? Then from this to this is a plus 7. So you're adding 2 more than you did before. From this to this is a plus 9. So each time you add, you're adding 2 more than you did the previous time, right? From this to this is a plus 11. From this to this has to be a plus what? 13. That's why the answer here is 46. Yes. 46 is the answer. Beautiful. Next one. Write this number as a common fraction. Come on, quickly. 20 seconds to do that. Write that as a common fraction. 0.45 written as a common fraction. And I want it in simplest terms. Huh? A. All right. I see. 8. All right. So first I will write this other fraction by putting it at 45 over 100. And then these two numbers can be divided by 5. So divide each of them by 5. Then the final result becomes 9 over 20. Yes. So that says A for A. 9 over 20. All right. Next question. A certain amount of money is shared in ratio 2 to 3 to 1. The difference between the first and the second share is 40. Then the amount of money shared is what? Come on, 1 minute to do that one. Come on. A certain money is shared in the ratio 2 to 3 to 1. The difference between the first and the second share is 40. So these are the ratio of the first and the second share. Difference is 40 in the actual numbers. What is the total amount of money shared? We can extend the ratio to show the difference and total. Ratio that they give you to show the values, representing the values. You can extend that ratio to show a part for the difference, or a part for the sum. Right? You can show the difference, you can show a part of the ratio for the difference of the two first one. And because you know what that is, the difference of the two first one is 40. Pay attention. Want another 10 seconds? You say B. Somebody said B. D as in dog. And where? Anybody else? All right, pay attention. A question like this is the 2 to 3 to 9 that was given, right? I'm going to extend it in blue and put in a section for the difference between the first two, which is 1. And also extend it to show the total. Where the total is some of these things is what? 14. The difference is supposed to be 40. Right now, the difference in ratio is 1. And if I want the values to reflect what they actually are, I need to multiply this by 40. And when I multiply this by 40 as well, I'm going to know what the total is. When I multiply the difference by 40, it becomes the 40 that we know what the difference actually is. And I want the total, so I need to multiply this by 40 as well. But understand that? So the 40 times this is 560. So the answer, yes, is 560. See? 40 times 14. Same as 4 times 140. Right? 560, that is it. Oh, sorry. So the answer is 560. All I did there was extend the ratio to reflect the information that they want, and they gave us a lot. And that's it. If you wanted to know any individual of these, you have to multiply by 40 as well. Each of them. All right? Next question. This one. Come, 30 seconds to that one. Our question is supposed to look for it and go and say, if you know the Pythagorean triplets. Like the Pythagorean triplet from Pythagoras' theorem. More things you know, the better in maths. So you have what we call 3, 4, 5 triangle, Pythagorean triple, 3, 4, 5. We have the 5, 12, 13. Then another popular one is the 8, 15, 17. So this is for the 8, 15, 17, Pythagorean triple. So the missing figure is the 8. So the answer is 8. Get me? But I said it didn't know. They said it wasn't the Pythagorean triple and want to replace. You can't use a calculator in the exam, right? Because you know what 17 squared and 15 squared is. You can't use a calculator in the exam. So let's say the one you can't use a calculator. I recognize this under here as a difference of 2 squared. And so this will become the square root of 17 minus 15, 17 plus 15. And simplify it. 70 minus 15 is 2. And this plus that is 32. 2 times 32 is 64. And you almost know that square root of 64 is 8. If that question like this with different values, then that would be a nice way to do it. But knowing the Pythagorean triple, I mean, I tell people all the time, you know, the more things you know, the easier life is in maths. If you don't know the Pythagorean triple, the 8, 15, 17 triangle, you know the answer for this one is 8. This came out of the Pythagorean triple. On the right hand, yeah? Yeah? Huh? Huh? I'm going to get the 32. Plus 17 and 15 is 32. And 17 minus 15 is 2. So I write this as a difference of 2 squared. I'm saying, but if you know the Pythagorean triple on the right hand triangle, when the hypotenuse is 17 and this side is 15, on the side over here is 8. 8, 15, 17, Pythagorean triple. Right? I gave you that list of Pythagorean triple when we did Pythagoras theorem. I said, learn the math over there. More things you know, the better in maths. You have to work out everything in maths when you know stuff. All right, this one here, quickly. 20 seconds to do that one. That is 20 seconds to do it. Pick on fast. 13. But the negative 2 squared is 9. And the negative 3 squared and the negative 2 squared is 4, right? That equals 13. That's his answer. What if instead I gave you this? Anyway, negative 3 cubed plus negative 2 cubed. What would be the answer for that one? Nothing to give that one before. Huh? 35, you said? You said 35. Where you? You said 35. The 35 code. But that's wrong. Because what you have to realize is that when you raise a number to an odd power, it's going to come back negative. You have to realize that when you raise a power, when you raise a number, you raise a negative number to an odd power, it's coming back negative. When you raise it, huh? Because remember, you do the negative 3 times the negative 3 times the negative 3. That's what it is, you know, negative 3 times negative 3 times negative 3. So them two are going to become positive 9. They multiply by negative 3. But you need to know that when you raise a negative number to an odd power, it's going to come back negative. Get me? When you raise to an even power, it come back positive. So this is actually negative 27. And this is actually negative 8. So negative 35 is the answer right here. All right? So remember, raise up a negative number to an odd power, sign come back negative. I multiply the negative 3 times. 2 other times, then cancel each other. All right? This one. What number is added to 1 1/3 to make it 2? Easy. Huh? You have 1 1/3 and 1, if you go to what you have to do? 2/3. Easy. That don't need no calculation. 2/3. All right. That is one. Do that one for me. This divided by that. And let me do this one and then give you one thing, but this is another one on the screen. First thing I would do, make it simple. Write this as a fraction and then invert and multiply. So I'm going to write this as 11.1 divided by, and this is actually 1 over 100. That's what this is. Because I'm dividing, I'm going to invert and multiply. So it becomes 11.1 times 100 over 1. That can multiply by 100. They move the decimal point 2 places to the right. So it becomes 1110. So that's this one. See that? Do this one for me now. Similar. This is a division symbol. So it's 22.2 divided by 0.02. CMD. You get B. Let's B and again. RD. D, R, B again. So same thing. 22.2. Change this into a fraction, which is just divided by 2 over 100. Then invert and multiply. 22.2 times 100 over 2. That's all. Get your power up. You try it. I was sitting at the bank of question and start work on them. I do a paper. You have any paper you have not done yet? You have any paper ones that you have not done yet? Which one don't see it? Come on, why do a recent one? Give me a recent one you have not done yet. I think I did. 24, 23, 22, 20, and do all of them go down already? All right, so this one now, we're simplifying this, guys. Don't trouble them numbers here. When you're doing multiple choice exam and you can't use a calculator, you don't trouble numbers like this. You get me? You don't divide this and turn it into 50. Make it more complicated. You want to leave numbers like 10, thousands, hundreds. Or do I easily multiply with? You get me? You don't trouble numbers like those. So you cancel this with this and turn this in 11.1. And you multiply by the 100 now, see it? So it becomes the last one. 1, 2. 2 places to the right. That is it. So don't turn the 100 over 2 into 50. You want to keep the numbers like 10, hundreds, thousands, keep those numbers in the calculation. All right? So that is the multiply with. All right, this one now, this one for me. 12.5% of a sum of money is 40. What is the sum of money? Do that one for me. Don't know the sum of money. 12.5% of a sum of money is 40. What is the sum of money? Remember, the answers are on the paper right here. So if you can't work it out, if I'm in the exam, I'm going to try, well, it can't be this. I'm going to try 12.5% of each of them and see which one give me 40. If I'm in the exam, I don't know to calculate. Just work out 12.5% for each of these and say which one of them give me 40. That's how I would do it in the exam if I don't have a calculation method to do it. You get me? Just work out 12.5% of each of them and see which one of them give me the 40. And get the answer that way. But work it out, let me see. No way again. 12.5% of a sum of money is 40. What is the sum of money? D, B. All right. Anybody else? What else? Good? Ready? I'm sure I need you to do it. I'll show you two ways I could make it. So, okay, 12.5%, which is 12.5 over 100 for a certain amount of money is equal to 40. And trying to find this. So I'm going to multiply the 100 and divide on the 12.5. So it will be x equals 40 times 100 over 12.5. And you're working this down. So this 12.5, I don't want it like that. So I would say maybe write it as, well, this 40 times this is really 4,000, right? So it will be 4,000 over 12.5. What I'm going to do is multiply under here so by a 10. And multiply up here so by a 10 as well. Because I don't want to work with 12.5. I prefer work with 125. So I'm putting an additional 0 on this by multiplying by this 10 and put 125 on here. And then divide it down. Divide it down after that by 5 or 25 or whatever. Divide it down. 5, 5, 5. Right? So divide it down. You get the 320. All right? Divide it down by 5. So 5 into this goes so much. 5 into this goes so much. 5 into this, 25. And 5 into this goes what? 8. That's 8,000 right now, right? Then 5 into this again goes what? 5. And 5 into this goes so much? Huh? 1, 6. So 1, 6. 16, right? And then 5 into this goes 1, and 5 into this goes 1. 320. All right, watch this now. Try easier way now. Watch this. We'll do it like a ratio. We'll say, all right. 12.5% is 40, right? So 100% represents the number, don't it? Right? 12.5% is 40. So if I carry that up to 100, then I have the number. So watch this now. 12.5% is 40. I want this to become 100. It in stages. Multiply by 2 first. And carry it up to 25 first. So it means that 25% is 80. Then to go from 25% to 100% when I multiply by 4. So multiply by 4 now, because I want this to become 100%. It means that 100%, which is a number, is 320. That's 320. Huh? Where? Yeah, man, you can time this by 4. Because I multiply this by 4. So anything do it like a ratio. 12% to 40. I want the 12% to become 100. When the 12.5% becomes 100, then this always becomes the number that it is, to 100%, right? The actual number is 100%, right? So just get multiplied gradually, right? And that's a nice, quick way to do it. Rather than to do all of that. All right. Next one. Says a test was marked out of 80. A boy scored 60% of the marks on the test. How many marks did he score? That's one easy. Huh? 48. He was doing 60% of the 8, right? 60 over 100 times 80. So in terms of the substantive number you're multiplying, it is 6 times 8, which is 40. This is the only answer with a 48 in it. That must be the answer. 48. Next one. There are 40 students in a class. Girls make up 60% of the class. 25% of the girls wear glasses. How many girls in the class wear glasses? And remember, I know we can change this question after. How many girls do not wear glasses? Yeah, man, so oh, careful. Don't think it's the same question that should repeat. 40 girls, 40 students in the class. 60% wear glasses. 60% are girls, and then 25% of the girls wear glasses. How many wear glasses? It's an A. Practice without the calculator, my boss. Yeah, calculator exam. Practice without it. If we get into the mode of practicing without it. Get me? Later, right? Watch this now. So, watch this now. So 40 students, right? 60% are girls, right? So the girls are 60% times 40, don't it? These are your girls. And then 25% of those girls now are the ones who wear glasses. So you want 25% now of these girls. That is the calculation. So this 25% is really just a quarter, right? And the 60% of the girls, if you cancel out the 0 of them, you get 24. A quarter of 24 is 6. So yes, the answer is 8. Right? But the 25% is just a quarter. Quarter of the girls. And the girls is 24 girls. That's it. 6. All right, that's how I finish. So CSEC change question. These are 2 different questions from 2 different exams. Now, if you do a lot of past paper, then you say this. By the way, this is what? This is a square. I say another exam, just put a negative on it. And the answer is different. So you cannot go in there swatting answers. You have to look carefully and say, look at these. The answers are the exact same, on 2 different exam papers. So if you always do this on past papers and say you click to them, say swat the answer, and then change this, and you don't notice that there's a negative on that, and you go by swatting answer, you might just choose the wrong answer. You know what I'm saying? So let's not swat answers. By the way, read them out for me. 2 of them. Them on again. You know what the negative on a power mean? Negative on a power means reciprocal. Negative on a power means reciprocal. Like if I have 2 over 3 to the minus 1, it means 3 over 2 to the 1, which is the same as 3 over 2. So the negative power means you flip it. So then this fraction that they gave us is the same as if I apply the negative, it becomes 3 over 2 squared. Because the negative means reciprocal of this. The negative means reciprocal. Then it becomes 9 over 4. It becomes 9 over 4. Is this one. While over here, the answer for this one is just 4 over 9. CMD as well. 4 over 9. 4 over 9. CMD. CSEC, what is the number? 4 over 9. But if you know the answer for this is 4 over 9, from practice it. I think these are the same question. Might go put the answer here, so it's wrong. Get me? I come out and say, get it right. Yeah. So I want to be careful. You got to be careful. All right, next question. This number correct the 3 decimal places. Come on, work out and them on again. 3 decimal places, correct at the 3 decimal place. What's the answer? But I agree that is B? Yes, B is the answer. Next one. This one inside, we did this earlier, right? We discussed that earlier, don't it? Decimal point is coming here. The answer is this one, right? All right, I did this one earlier. And we did this one too? No, it's right, different. We wrote it differently. So it's 560 are sharing ratio 2 to 3 to 1. The difference between the largest and the smallest is what? 80. The largest and the smallest, no, this and this. I don't know the answer. And I've worked out and tell you. Go on, read it. The largest and the smallest. One that we did before said the difference between the first and the second, 2 first ones, was 40. The difference is than this now. You can do the same way. Huh? See? What you can see? The difference between the largest and the smallest share. Yeah, C is correct. All right. So how I would do it? So all right, 2 to 3 to 9. Extend the ratio. You put in the total. Gotta give us the total. And the difference between the largest and the smallest. So the total part is 14. The difference between the large and the smallest. The difference between the large and the smallest is 7. Don't it? That's all. And you can recognize that the difference between the largest and the smallest is half. See that? So the total is actually 560. Then the difference is going to be half. Because right now, the difference, the relationship between the total and the difference is a half relationship. You get me? So half of this is the answer. See what I say? Because in the ratio, the relationship is half. So in the actual total, the relationship is still going to be half. So the actual difference is half of 560, which is 280, right? But if you want to make the ratio show the actual thing, what do you multiply this by for it to reach 560? That's the question. What do you multiply that by to reach 560? I think the easiest way to recognize that is a half relationship. This to this is half. Therefore, the actual difference is half of the 560, which is 280. But this relationship is a half relationship. That applies to the total. All right? That's how you could look at it. This one from in this box. 350 share there is a 2 to 5, then the smaller share is come fast. Huh? John? 100. 2/7, right? Smaller share is 2/7 times the 350. All right. 60% of our number is 90. What is 4/5 of the number? Do that one for me. 60% is 90. What is 4/5 of the number? B again. Anybody else? What is 4/5 of the number? 60% is 90. What is 4/5 of that number? 60% of our number is 90. What is 4/5 of the number? What do you get? A. What you get? C. Anybody else? You guys come on and do some work on the bar. We keep practice with the calculator and I'll improve. We keep practice with the calculator and not going to improve. You now have a calculator, X and you have to force yourself to work without it, my boss. You have to work without it. It's a C. Anybody else? All right. So what is 60/100 times some number that I don't know is equal to 90. You can do this 2 ways. I can find out what that number is first. I can work out what the number is first. And then having worked out the number, then we do 4/5 of the number. Don't it? Okay, work out this number. This over here says actually cancel this. Multiply 900/6. I can work this down. This time become 3/5, right? So 3/5 times the number equals 90. And actually I want 4/5. That's a 3/5 that? 3/5, yeah. And actually I want 4/5. You want 4/5, right? So I can work out the number by multiplying by the 5 and then divide by the 3. So I can say the number becomes 90 times 5/3. So that number equals what? I work out the number first. All right? 3 into this goes 30. 150, right? The number is 150. And then up, and then therefore 4/5 of 150 you want next, right? Which is what? 4/5 of 120 of that is what? 120. So that says 120. That is it. But watch this now. Watch this as well. So 60% of a number is 90. Can we work it out without actually working out the number, you know? Recognize as 3/5 still. All right? 3/5 of the number is 90. All right. I want this side to become 4/5. So it means that I don't want this 3. I need a 4 over there, don't it? What I'm going to do is, okay, I'm going to divide by the 3 and also divide this side by the 3. And then multiply this side by 4 and multiply this side by 4. Because I want this side to become 3/5 and 4/5. So for this side to become 4/5, I don't need this 3. So I divide by it on this side and divide by it over here as well. And then now I multiply by 4 because I want the 5 to stay. All right? So the 4/5 of the number becomes whatever that calculation with the same 120. But maybe most girls with this, we're going to work out the 150 first and then find 4/5 of the 150. We could actually do the 150. Let's go from 3/5 to 4/5. Divide by the 3 and multiply by 4. That's what it is. Divide by the 3 and multiply by the 4. All right. All right, over here now. Same question. Your time again. See that? 30% of a number is 45. 4/5 of the number is what? Come on. A second chance to do the question. Come on. These are the same question with different values. Everybody want to get? Huh? Again? Yeah, you get 120 again. The same question, you know. They gave 60% is 90 a while ago. Now they're saying 30% is 45. It's the same numbers. If 60% was 90 a while ago, then 30% is in fact 45. It's actually the same question. And that just change the values. So that's why still 120. If we were to work it out again, we could say 30% of some number is equal to 45. All right? And you're trying to find it. So this cancels into that. So the number becomes 45 times 10 over 3. That becomes 150. Therefore, 4/5 times the 150 is equal to 120. So this is the answer again. This one here now on the screen, this one. But these two. B, you understand? Up here, sir? Up here, sir, B, don't it? Because this close to half, right? Of 45, of 43. So there must be a number in the 10 zone. What's up? It's only a number in the 10s, this one. But if you look at the movement of the decimal places, decimal points, sorry, from this to this is 1 to the right. That's a +1. And from this to the same value. So it's a 1 to the right. Plus 1, same way. So the answer is B. What about this one down here, so now in the dark box? What about that one? What's the answer for that one? B again? Sure? Look here. Not be smart, you know. Look again. This is about half, you know. That's about 0.5, you know. Half a 370, have to be 100 and something. So it can't be, it have to be a number in the hundreds. 0.43, close to half. You get me? You know, quite reach half, but close to half. So it has to be a number in the hundreds. So again, has to be C. Get me? But you could look at the decimal point movement again. But this one to this one, I'm usually ready. So this to this, decimal point move one place back. That's a -1. And from this to this, it moves what? 3 places to the front. 1, 2, 3 places forward. That's a +3. That's a net movement of +2. So me say this I will move 2 places to the right. This decimal point, +2. The decimal point will come right there. So that's why this is the answer. All right. This one. A total of 540 beads are shared in ratio 4 to 5. The larger share is what? C. Because it becomes 5/9, not it? Times 540. 54 divided by 9 is 6, right? So it becomes 54 divided by 9 is 6. 60. That's 200. Next question. The first 3 common multiples of 3, 4, and 6 are. What's that about this one? First 3 common multiple of 3. D has to be the answer. First, this is not a multiple of 8. Did that make it wrong, right? Don't it? And that's not a multiple of 3, don't it? The one common multiple. So the answer has to be the last one. This one over here. Dan sold 40 concert tickets in 5 days. Each day he sold 3 tickets more than the previous day. The number of tickets he sold on the 3rd day is? And then there was another question here. So Dan sold 40 tickets in 5 days. Each day he sold 3 tickets more than the previous day. What is the ratio of the number of tickets sold on day 3 to the number of tickets sold on day 5? It's a similar question. Basically, the same question, but they're asking 2 different things on them. Come on. Do 2 of them for me. I'm giving you 2 minutes, 3 minutes, minute and a half each. What that thought for me? Try that, miss what you do. He sold a total of 40 tickets in 5 days. Each day he sold 3 tickets more than the previous day. The number of tickets sold on the 3rd day is, and then the part down here wants the number of tickets sold, the ratio 3rd day to 50. Okay, guys. I told you guys to do the advance, right? You know, I'm not going to that. And she's in our character about one answer them straight. And tell us the advance one which I said on CSEC. It's 4 or 5 places that. Yeah, but I'm telling you, she actually was using our character about dancers and I'm that there. So then, because I said, I'm gonna tell them last year, never believe me. When we tell she last year, never believe me. I sit back and compare and say, I can't find this. No, I can't get this problem. So I said, okay, that. I love the stand mirror, understand. It's like everything else. I don't know what it says. Close. Get the guy. It's better white. Everybody get it? All right, let's go. Pay attention. So this is one of them questions here. Here, I can't think of a shortcut way to do it. All right? So let me show you how I would do it. So how I would do it, you don't know how many tickets they sold on the first day. So the first day you sold X tickets. Second day is X plus 3, then X plus 6, then X plus 9, then X plus 12. 1, 2, 3, 4, 5. That's a total of 5x plus, what is that up to now? 30. That equals 40 tickets. So x equals 2. So if x equals 2, then the third day is 8. So the answer for this one is that, right? And the fifth day is 40, noted. Noted? So this ratio over here is 8 to 40, noted? Which reduces to 4 to 7. See that? Nice and easy. So that's hard after all, but put in the we don't know as x. I work it out. Look what it says. Very good. Yeah, number boss. We don't understand. What about you, sir? I don't know what they started out selling. But I know they sell 3 tickets more than the previous day. So maybe the first day amount be X. And then I write what each day would be. This is the first day, this is the second day, third day, fourth day, fifth day. And I told that the total was 40. Now all of this add up to this right here, so. And they're telling us that it was actually 40 tickets. So from that way, now I can work out what the number of tickets on the first day is, which is X. It's 2. So X is 2. So therefore, this is the third day, which is 8. And this is the fifth day. So this question asks us for the third day alone. So the answer is 8. This is the same question, you know, but it asks us for the ratio of the third to the fifth day. So it becomes 8 to 14. 8 to 14. That reduces to 4 to 7. It's the same information, asking something different. Get me? Yeah. All right, good. This one. These 2 questions. Come on, 2 of them. What the square root of this lie between which 2 and the square root of this lie between which 2? Come on. Number 4C. Two of them are the same answer, 13 and 14. Because look, 13 squared is 169. And 14 squared is 196. So the 181 is between them, not it? Same thing I'm doing, so I can literally copy this down. The 190, 191 between them as well, right? That's the answer. All right. Next question. Oh, that done enough. I'll do the set. I'll take a short break and then we'll do another topic. What are the algebra next?
Probably get wrong. I do this one, you know,
Graph.
because me never know enough of you know to open the paper before the time, you know. So me I go to the paper, I see it on myself. So I know. But
15 minutes break.
sir, no, do 16, no, sir. We're on it off, keep it on.
One a man.
I tried to get you one.
Then we will try the three topics today. Algebra, then the matrices, the short topic. Algebra matrices, and then it will vectors, short topics. And those topics don't come a lot on the exam paper. So then we do that. Here. Hey. All right, ready again. Let's go, let's go. Algebra time. This first question here. It says the product of this number and its reciprocal. What's the reciprocal of a number? Let's flip it. Good. So you want the product. So it becomes, it's really 2p over 3 times 3 over 2p. So after that, let me express here. So that one is what? C. And this one, same thing. The product of P and its reciprocal is this one down here, right? P and 1 over P. Product of a number and its reciprocal. Jordan, don't know, no? This question says, it's referring to that rectangle. You can say the dimension of rectangle is a 2 times x minus 4, 2 by x minus 4. He said the area of the rectangle is x squared. The area of this rectangle is actually x squared. He said the equation that may be used to find the value of x is which one? The area is x squared. Which one of them can be used to find x? The tell you the area is x squared. The first one, this is the area. It's actually equal to 2 times that, no sir? The answer is A. And the area is 2 times the product of those two sides. Until it's x squared. This one, alpha normally saves x. We did discuss another day yesterday, you know. She normally saves x dollars each month, but in June she saved 4x more than twice her usual amount. In June she saved what? Which one?
No, sorry.
More. I think the one that we did yesterday was something about was 4 less. This one is 2 more. This one, no, she saved 4 more than twice usual amount. The answer is this. Twice usual amount plus 4. That's what she saved, right? Next question up here. We're solving this for x, guys. Solving that for x. Now, what if I'm in the examiner, I can try some of them policies in here and see which one work, you know. Right? 5 work. 5 can't work, man. A -1 work. If you put -1 there, I got 3 plus 2 over -1. 2 over -1 is become -2, so it's 3 minus 2. 3 minus 2 is equal to the 1 over here, so. But let's say you can't do, you have to solve it. You're solving for x. Basically solving this for x. What you're doing, you know, solving for x. So this equation would become 2 over x equal 1 minus 3. So 2 over x. 2 over x, not 2 over 3. It will become -2. Good? You want to make x a subject, you can multiply the x and divide under the 2. So you get x equals 2 over -2. 2 over -1, so x equals -1. So the answer is this one. So you're solving for x. It's part of the paper, you're solving for x. It's the algebra part of the paper. All right? Another question here, solving for x. Come on, do this one for me. This time it's 3 plus x over 2. See? That's why you have to be careful and don't start the question. See it? Look up here now. This is 3 plus 2 over x, you know. And I set by the same question basically, and just put x over 2 instead. See that? What answer for this one? B. Huh? B. Yeah, answer B. Because it's the same thing again, you're solving this, right? So carry over the 2 first, you get x over 2 equal -2. Then you multiply the 2 here, so x equal -2 times 2. X equal -4. Answer is B. This one, come on, do this one for me. But this is the same as which one I did. Remember, you multiply indices, you add the powers, right? Add the powers. Huh? Yes, B is the answer. You're adding the powers. It becomes 5 to the n plus 1 plus n plus 2. That becomes 5. N and n is 2n. 1 and 2 is 3. So the answer is B. This one, operation, binary operation. Where this one not coming? But this one, remember, you have to do what is in the bracket first. Come on, I give you a minute and a half to do that. Come on, or a minute. You don't need more than a minute. I say they don't work with the final value. They have not worked with the final answer. A star B means the square of the first one plus the square of the second one. That's what basically saying. 3 square. You work out the value of what is in the bracket first. And then you start that result with a 2. Work out what 3 squared plus 4 squared is first. Here's the answer. Good. Because what happened is that the 3 star 4 initially is 3 squared plus 4 squared, which is 25. So it means that this thing actually becomes 25 star 2, which then is 25 squared plus 2 squared. Which is this. See that? All right. Next question. Well, do this one coming. When 6 is added to a number and the sum is divided by 3, when 6 is added to a number and the sum is divided by 3, the result is 4. This statement written as what? But I will be 6 is added to a number x, and the result, that's it, the result is divided by 3. The sum is divided by 3, the result is 4. So the answer is this one. When 6 is added to a number, the sum is divided by 3, that's it. Next one. Tell me this one now. When 5 is added to a certain number, the result is multiplied by 3, final answer is 27. What is the original number? Come on, do that one for me. 5 is added to a number, and the result is multiplied by 3, final answer is 21. Write it like an equation. Put the unknown as x or something like that. And solve for the x. You got 4? Hmm? 9. Right. That's what we're for, right? But go to that. I'm doing like an equation, I will set up like this. 5 is added to a certain number. Certain number is added to 5. And that result is multiplied by 3. The final answer is 27. Solving that for x. 3 times 9 is 27. So this has to be 4, right? But I agree with that. If you solve it, you're going to get x equals 4. X equals 4. Another one. When twice a certain number is subtracted from 7 and the result is multiplied by 3, answer 33. What is the original number? Do that one for me. When twice a certain number is subtracted from 7 No. Yes. Now again. I don't know that work though. All right. That's you. That's you. Get 9 though. Twice a certain number is subtracted from 7. Twice a certain number is subtracted from 7. Shows a 9. Twice a number is subtracted from 7. The negative number. Twice a certain number is subtracted from 7. Set it up like an equation. Look. Twice a certain number is subtracted from 7. That's 7 minus twice a certain number. When twice a certain number is subtracted from 7 and the result is multiplied by 3, the final answer is 33. That's what you're solving. Twice a certain number is subtracted from 7. That is multiplied by 3. Final answer is 33. You're solving this for x. So divide by the 3 you're supposed to get 7 minus 2x equals 11. We can carry this over here and make it positive 2x. Take the 11 and bring it over here so you get negative 4. And so the x equals negative 2. Set it up like an equation. Or just you can guess and wonder. And then round. Okay, I try to put an head my own. Make the mathematics work for you. That's what algebra is about, you know. Turning statements into mathematical expressions that can be solved. So the unknown, you call it x. I write to themselves an equation. Twice a certain number is subtracted from 7. That's what this is, you know. Twice a certain number is subtracted from 7. And the result is multiplied by 3. See there, this result is multiplied by this 3. The answer is 33. See there, the answer is 33. And then solving that for x. So the first thing you have to do is take that statement and write this equation to solve from what I've said. Next one, the product of these two numbers is what? The product of them, that's negative 2a times negative 3a. What is it work out to? Huh? What again? Can be 6a. 6a squared. The negative 2 times the negative 3 become a positive 6. Then the a times the a is a squared. 6a squared. Easy question. P over 5 is 20. What is P? Which one is P? P times 5. 20 times 5. 35 and multiply it up here, right? Next one. P plus 1, P plus Q is negative 1 and P Q negative 6. What is P cube minus P cube plus Q cube? We have to work out the P and the Q. So the product is negative 6, or the sum is negative 1. What are the values there? The product is negative 6, and the sum is negative 1. So one must be 2 and one must be negative 3, and so on. Isn't it? That is it. And then when you find the P, when you find the two of them, which one of them larger? That to be one is 2 and one is negative 3 because the sum of them negative. You see that? So the product is negative 6 and the sum is negative 1. So it means that P equal -3 and Q equals 2. Either way, it doesn't matter which one. So the PQ minus the thing, the Q cube now becomes -3 cube plus 2 cube. That's -27 plus 8, -19. But that's not a calculation. But understand that P is -3 and the Q is 2 by looking. The product of the two numbers is -69. So you know the one positive and one negative. And the sum of them is -1. Some of them is -1. The product of two numbers that is -6. It must jump out at you that is 2 and 3 them are 2 and 3. Product is negative is 6. But one positive and one negative. Then if the sum of them negative, they have to give the larger one the negative sign. So I make the Q equal, the P equal -3 and the Q equal 1, equal 2. Can go the other way around to them. Can be that the Q is the -3 and the P is 2. No matter. You may not be done. That is it. This one down here now. Come quickly, this one for me. X is -2, Q is Y, T is 2. Work out this thing. Put those values, put all these values in there. And come on again. A again. Cannot be A. Cannot be A in a gateway. The power will be a square. So that's a can negative. Come on, man. Can't do them something like this, man. There's certain things they just don't make no mistake, it don't make no sense. The power of a square, the answer can't be the negative one. Because you're going to square the power. The 2 is the square, is the power. So the answer cannot be the negative answer. You have to know, so when you raise a power, you raise a number to a square or an even power, the answer must be more positive. At this level, you have complex numbers to do at pure mass level, but no, that's not here. Right? So this becomes -2/3 squared. You have to come out +4/9. This one, don't give it away. See it? Have to come out positive. All right, next one. All right, let me start this now. I think this is 2x. I think this is, let me see if I can sort it out. Fine. Fine. Sorry. All right, it's like 3 to the 2x plus 1 equals 9 times 3 to the x. I'm solving that for x. Come on. Solving this for x. That's an indices question. Bring everything to base 3 and solve it. Use laws of indices. Solve that. That's 3 to the 2x plus 1 equals 9 times 3 to the x. And try to find the x. Bring both sides to base 3. Right, both sides are indices with 3 using the laws of indices. Come now, turn around and work the man. Gentlemen, to the word the man and stop play. Why panda? Go. Ready? Better get it? Bring everything to base 3. Same question I'm going to problem for go do them over here. I make sure now, so I understand what we do them. We're going to get 58 or more in the exam. Any question I give you a problem, you can go and work it out. No, listen to me now, guys. In the exam, you can't do understand that. You can't work out the X. The answers are there on the paper. Try them in and see which one work. You get me? But I guess something you can work out. This is a numeric question. So all you have to do, try 0 for the X and see what you get. Try the 0 this and this and see the two sides equal. That don't work. You try the 1 or the 3rd. Try the 3rd, this and this. I would have tried the whole number them first, actually. So I would have tried the whole number them first. Easy one then. Right? Put the 1 here so and there so and see the two sides work out to be the same thing. You get me? So when you can't work it out, try the values in the question and see which one works. Nobody guess where you can work out. It doesn't make sense. Try the answers in the question and see which one works. If you can't actually work it out. Because the answer is there on the paper, the right one is there. So you try and see which one is the right one, which one works in the equation. You understand what I mean by try the answers in there? Yes. I'm demonstrating what I'm going to say. Okay. If I'm in the exam, I'm going to try, but I try 0 first. So I put 0 this and 0 this up. So it should become 3 to the 1 on the side, I put 0, equal 9 times 3 to the 0. 3 to the 0 is 1 enough. That's not right. Because that's out of bit 3 and that's out of bit 9 times 1. So that no work. All right? 0 don't work. I'm gonna try a whole number for me. I try that 1 here next. This. So I put the 1 in this and the 1 in this. So we have 3 today. If we put 1 in here, so that become 3 cubed. Equal 9 times, put the 1 in this, so 3 to the 1 is 3. That works. Because this is 27 and this is 27. So the answer is 1. You get me? The answer is on the paper. When the question is numerical like this, try them and see which one works if you can actually work it out yourself. Cool? Well, let me show you work it out now. Because you don't know what's coming in the exam paper. But basically, I want to bring the two sides to have the same base. This 9 same as 3 squared. So I write this as 3 to the 2x plus 1 equal this 9 is 3 squared. So it becomes 3 squared times 3 to the x. This is 3 squared times 3 to the x. Now what do? You add the powers. You multiply indices with the same base, you add the powers. So that's how it becomes 3 to the 2x plus 1 equals 3 to the 2 plus x. What are the two sides of the same base? It means that the two powers them equal. Let's change the color to red. And say, therefore, 2x plus 1 on this side is equal to 2 plus x on this side. So we take the x here and bring it over here and subtract, we get x. Take that 1 and bring it over and subtract from the 2, we get 1. So x equals 1, so this is the answer. Understand that? But if you can't do the calculation, like a question like this, you try the answers in the question to see which one of them works in the question. All have to do. Very good? All right. This one, 3 questions are almost the same. One of your time. Algebraic fractions, I want the two denominators to be the same. So all of it, you want to use the primary school method probably. You're adding fractions. And when the denominators are the same, you just add the numerator. The denominator different, you want the two denominators to become the same. So you adjust for the two denominators to become the same. Want to finish? I'm doing the first one. And then you guys do this. Look. I want these two fractions to be added and I want the two denominators to become the same. Multiply this denominator by a 3 over 3. The two denominators can become 15x, don't it? Multiply this fraction by 3 over 3. Multiply this fraction by 5 over 5. 5 over 5. You see, this denominator is 15x, that denominator is 15x. So this actually becomes, with a common denominator of 15x, sorry. This numerator is 3. And this numerator is 10. That becomes 13 over 15x. Don't matter one there, no, that's squared. Careful, this one. All right, based on that, do this one in the supplement. Do this one in the box here, supplement. Quickly. Five or 6x. So I got multiply this one by 3 over 3. Multiply this one by 2 over 2. 2 them 2 over 2. Just a short. 2 them denominator becomes 6x. Numerator becomes 3 plus 2 is 5. 5 or 6. Don't matter one then. This one is the answer. Careful and don't matter wrong. All right, this one's straightforward. This one over here. 6 over 10. 6 over 10. I get 10x. 6 over 5x. Right. You put this one here wrong. The two denominators are the same. So just add the numerator value and put by the common denominator. 5x is the common denominator. Numerator add to 6. 6 over 5x. This is the answer. This one here. Which one is that? A is the answer. Next one. What is the value of that if x equals 4 and y equals 2? Where do I go from? Quick. Huh? D again? But get D? Ready? So the x squared is actually 4 squared, right? Let's write it out. It becomes 4 squared plus 3 times the y value, which is 2 over 4 times 2, right? This is 16 plus numerator is 6 over 8. That's what we're doing, right? That becomes 22 over 8. And we can divide 2 by 4. Divide 2 by 2. Divide each thing by 2. It becomes 8 plus 3 over 4. See that? This is the same as 8 over 4 plus 3 over 4 now. It becomes 2 and 3 quarters. Answer is D. Good. Next question up here. Find the value of x in this one. Come on. Easy. You can see. You can see it up. So much I get the wrong man, I say see. Look here. 5 times y equal 35. This have to be 7, you know. In order for that to be 7, this have to be 8, because 8 minus 1 is 7. In order for that to be 8, x have to equal 4. But if you even never do that, you solve it. Come on, man. I can't give them as so easy, man. You divide by the 5 here, so first, you're going to get 2x plus 2x minus 1 equals 7. Go over the 1, you get 2x equals 8. You divide by the 2, you get x equals 4. 4 is the answer. Remember, if you can't work it out, try to value them in the equation and see if try them give you the 35. No problem working it out. Another way to just try the values and see which one gives you the 45. That is why in the exam rule, because I like this, now you do it, you get 3. When you're going back 2, you're not going to learn, you know. Go and try the 3 in the equation and see if 3 works. I say, what? Did you make a mistake with that one? You get me? Go back and you try the answers back in the question when you can. Because if you get 3 for your thing and you try the 3 in there, it's not going to work. That is 2 times 3. 2 times 3 is 6. 6 minus 1 is 5. 5 is 25. It's 35 that. So I realize the answer wrong. So some of you, when you finish the exam and you run come out and think, and you realize you need to go through and test the answers that you get in the questions where you can. Not every question is like that, but where you can, you go and do that, like the algebra questions. You can test a lot of the times the answers that you get, but it is numerical. These are numerical answers. They try them in the equation or the question that they get. All right? Don't just come out. Stay in there and test everything. Next one. John has X marbles and Max has twice as many as John. Max gives John 5 of his marbles. How many marbles does John now have? BSA? No, I'm going to work it out. You know, look at that. I work it out now. You know, I try to look for it and get the answer like that. I work it out. If you're right, X plus 5. So see here, you have John, and you have Max. Write it out. So you say, John has X. John has X. And Max has twice as many, right? So Max has 2x. Max gave away 5 of his. So Max now has 2x minus 5. And John got the 5. So John now has x plus 5. And because I didn't ask you how much John has. X plus 5 right here. This is the answer. See that? X plus 5. Next one. A is 3, AB is 6. The same question here. A is 3, AB is 6. A is 3, AB is 6. What is A squared minus B squared? B has to be 2. See that? If A is 3, B has to be 2. Means that 3B equals 6. So the B has to be 2. The B is 2. What is this? It becomes 3 squared minus 2 squared. What is it? 9 minus 4 is 5. Next one. Solve for y. This equation. And again, numerical. If you can't work it out, you can try the values in there and see which one works. If I work it out and get the answer, I'm trying it in there. Try the values and get in there to see which one works. Come work it out and tell me what I get for X, what I get for Y this one. Solve it like an equation and try to make Y something. Try to solve for Y. B you get? You get D as a dog. You get D too? Expand this side, it becomes 5y minus 10 equal. Expand this side, becomes 3y plus 12. Carry 3y away and subtract it, I get 2y equal. Carry negative 10 over there, so add it, I get 22. You divide by the 2, we get y equals 11. Good. Next one. Another similar question. See there? Solve that for x. Know that this is a common factor. Look at it. That's x minus 1. So I have 3 times x minus 1 minus 2 times x minus 1 equals 7. What is x? 3 or something minus 2 or something equal 1 or something. Look at it that way. That question is kind of easy. What again? What do you guys get? Huh? What again? A, B, C, or D? What is? All right. So what you know? 3 of this minus 3 of this equal 1 of this, right? Take 1 of this, right? So it's 1 times x minus 1 equals 7, right? So x minus 1 equals 7. So x of y equal to 8. See that? Huh? 3 of something minus 2 of the same something equal 1 of the something. 3 of this minus 2 of that equal 1 of that equals 7. See? But if you want to expand it out, you can do that as well. Expand out this. But it's important to expand with this if you consider the minus 2. So it will be 3x minus 3. And then minus 2x times that is minus 2x. Then it's minus is a plus. That's why people can get it wrong. That's a plus 2 equals 7. Then it's a 5, so another x. This one is a minus 1 equals 7. X equals 8. That is it. If you expanding it out, you realize minus there, so that's positive. All right. This one now, come on. How come you do that one? Minus again in this. One again. C. What else? C. The minus turns into 1 plus 2q. 2q minus 3q again. Negative q. That's it. Next one. That's the same as it was. B. The important thing again is the minus time minus turns into a plus right here, right? The answer for this one is B. You can see how they set this one. Look again. Careful, what that one equal to? What do you get for that? Huh? Get B? Can't be B. Because a minus x is going to turn into a minus x. You have a minus x, not the answer. It can't be B. Work out this first. Expand that with the negative first. They get 3 minus x minus is plus 2. 3 and the 2 is 5. So it becomes 5 minus x right here. So come on, man. Can't do it. I want to go to the exam, we get 40. But now work out what saying. Come, do this one now then. Come on. Get this one right for me. Come on. It's too easy, man. B?
Yes. Yes.
Careful now, so you have to careful at the exam, yeah? A lot of the times the wrong answer is there. You get a CXC know the mistake. CXC know the mistakes that people make and I put answers there to match the mistake. All right. So again, you're gonna expand out this negative bracket here, right? So this is gonna become 3x. This is minus 4x. And this minus 4 times minus 6 is positive 6 is negative 24. Oh, this is minus x. B. All right. That's that. This one for me now. If an integer is satisfying that, which one of them is this? We do this one. H you say. What is? Simple, you want x alone to leave in the middle. Divide it by 2, so you divide every way by 2. Simple as that. Oh. Right? So this become a 2. Yeah, well, less than sign stays less than. This now become x. Less than or equal to stays less than or equal to. It becomes 3. Answer is A, period. Very good. Divide all sides by 2. Sum of 2 positive numbers is 32, their difference is 12. What is the smaller number? Come on, do this one for me. Sum of 2 numbers is 32 and the difference is 12. What's the smaller one? The one? So like a pair of symbols which equation. Sum they add different ways of subtract. Everybody finish? Huh? Boss man. The sum of two something when you add them. The difference of two something when you subtract them. Write two equations and solve it. You can't see no look on the word. It's algebra. Work it out. Them say the sum is 32. So put P plus Q equals 32. The difference is 12. So put P minus Q equals 12. And then solve the two equations simultaneously. Even though the multiple choices still have to do work. There's a paper two, but you still have to do work. Small quantum and get the answers. Work it out. And I want the smaller one. Solve them simultaneously and I want the smaller one. The sum is 32, the difference is 12. I don't know if I work it out. I think it's too easy, you know, I'm beat on it now. The sum is 32. P plus Q is 32. The difference is 12. P minus Q is 12. That's a proof of simultaneous equation just solving. You get me? So to eliminate them two, you can just add the two equations quick. Add them. This is 2P equals 44. So P equals 22. So if P equals 22, that one is 10. Because see, take that 22 and put up here, so the Q is 10, don't it? Therefore, Q equals 10. Say them add to 32 and the difference is 12. So the smaller one is 10. Come on, man, everything is too easy, man. They tell you the information. The sum is 32, the difference is 12. Write it out and solve it. That's what algebra is about. Enough. We're not going to do plenty work in finance multiple choice. You can't get no 58 we own and go on. When I get 58, so I can't do the simple stuff. We're not going to do work for work. If you know an exam, come to speed with them simple, easy, baby question. So we can't do them easy, baby question for multiple choice. We're not going to do on the paper. I joke, man. Not joking. This one down here, come on. Some don't need this multiple choice and I better kill it. This one, easy, come on. 3 times x squared plus 2 times x cubed. What are we equal to? When you multiply indices, you add the powers. When you multiply indices, you add the powers. These are the indices, the expression that you multiply. So you add the powers. And this is 3 times 2 normally. That is 6. So it's 6x to the 2 plus 3. That is 6x to the 5th power. That is it. From this one down here, so come on. Them say this is x is, them say that they give you this and ask for this. No, this is m cubed and not a square, yes. So the first one is m and the second one is n. M cubed minus n squared. Write that out quick. Work it out. Ready? Is 11 or the square root of 11? Which one's the answer? It becomes the square root of 5 cubed minus 2 squared. That's all. Square root 5 cubed is 125 minus 4. Square root of 121. Square root of 121 is 11, right? All right, this one for me now. So they're telling you that 3 star 6 is 12, and 2 star 5 is 9. Which of these is A star B based on these results? They will use a trial error method, I guess. You can look and see which one makes sense. Just try them. We're gonna try these and see which one of them works on these two operations. I see that, sorry. Which one is the answer? D as in dog. What else? Which of these operations work so that this give you 9 and that give you 12? D as in dog. Yeah, 2 times the first one plus the second one. See there? 2 times 3 plus 6 is 12. And 2 times 2, what is so? Plus 5 is 9. That's D. Good? All right. Next one. When 8 is subtracted from a certain number and result multiplied by 3, answer is 20. What is the original? We do question like this earlier. Where is all coming? 8 is subtracted from a certain number and the result is multiplied by 3, which is 21. What's the answer? 8 is subtracted by a certain number. What is that number? Subtract 8 from a certain number, then multiply by 3, the answer is 21. D as in dog. All right, well, let's see. I'm going to 8. When 8 is subtracted from a certain number and the result is multiplied by 3, the answer is 21. When you multiply by 3, when 8 is subtracted from a certain number, when 8 is subtracted from, remember, so when 8 subtract a certain number, so when 8 is subtracted from a certain number. So I then put 1 there. If we read it the wrong way, you want to put 1 as the answer. You put in 8 minus 1. So that number minus 8, 8 is subtracted from the number. D. If you don't know, you can work it out. When 8 is subtracted from a certain number, see? That's me subtracting 8 from a certain number. And that result is multiplied by 3. The answer is 21. That's the equation based on what I said that is solving. So you divide by this 3, you get 7. Inside that's about with 7. So x minus 8, I forgot to be 7. So transpose the 8, the negative 8, you get x equals 15. Good. Algebra beating up bad. Beating up bad. You need to work. You guys need to work. Soon weakness. Algebra done. From matrices sharp, you can go straight to matrices. And then vectors. Let's go straight into the matrices. You guys, based on what I've just seen a while ago, you need work on the algebra. There's 8 questions on algebra. 8. You can't get majority of them questions around. Crazy. You can't put the exam less than 58, you know. 55 the lowest. So now we work on getting this question. And the beauty about almost all of these algebra questions, The answers are numeric. So you can try the answers in the question to see which one works. You have to do that. So I'm coming there, I see nobody come out in the exam room after half hour. Yeah, can I come out and leave marks in there? So I go through and check. Check through everything 10 times. You don't have to stay in there for the whole time. Because you know, put I like him now say one. One is the answer there. And people tell him say one is the right answer. Because they know the mistakes that people will make. And they put down the answers on the paper based on the mistake and the misinterpretation that people will make. So you're going to come out feeling say you're right. And to your mind, you read it right. Because I say 8 minus 1 is 7, 7 times 3 is 21. You're going to the next time. And I read the question, they say 8 is subtracted from a number. So that number minus 8, that's why the best thing to do is write it as an equation and then solve it. Rather than just try to figure out the number. That's what the problem with some of you try to figure out what it is. Anyway, let's go. The determinant of a number is, determinant of a matrix is 0. We do matrix C. Determinant of a matrix A is 0. What's a matrix called? Singular matrix. Singular matrix has no inverse, determinant is 0. They could have said an inverse A has no inverse. What kind of matrix is this? Same thing. Singular matrix. Next one. Two matrices A and B are conformable for multiplication A times B if, when are they conformable? When what? No, my boss. Number of columns in the first one of equal number of rows in the second one. Number of columns in the first one of equal the number of rows in the second. Remember, we set them up like for example, 2 by 2 times a 2 by 3. This is possible because this and this match. That's why it's possible. That's the number of columns in the first one. And that's the number of rows in the second one. It's a column. So the column in the first one. So the column in the first one. It's the row in the second one. They have to equal. Come on, man, pay attention to the details. So they put the wrong one up front. And I run with it. Number of columns in the first one, have to match the number of rows in the second one for it to be conformable. And the resulting matrix will carry the number of rows on the first with the number of columns in the second. The resulting matrix will have this by this, a 2 by 3. It will result. The resulting matrix in this case, in this example, will be a 2 by 3 matrix. And that is possible because the number of columns in the first is equal to the number of rows in the second. And they can ask that question about the resulting matrix as well. The resulting matrix takes the number of rows from the first one and the number of columns from the second one after the bullet. So the answer for this one is this. Number of columns in A, which is the first one, is equal to the number of rows in the B. So this is the answer right here. Next one, determinant of the identity matrix is what? What is the determinant of the identity matrix? Huh? What is the determinant of the identity matrix? The identity matrix is not a singular matrix. The determinant of the singular matrix is not 1, not 0. The identity matrix is this, 1, 0, 0, 1. That is the identity matrix talking about this one, 1, 0, 0, 1. Determinant of that matrix is 1. This product minus this product is 1. Determinant of this matrix, that's the identity matrix, is 1 times 1 minus 0 times 0. That equals 1. Because it's this product minus this product. Determinant of the identity matrix is 1. This is the identity matrix right here. This is the I matrix. Next one. A is equal to this. Then what is the order of that matrix? Which one of these is the order of that matrix? 3 by 4. Remember, order is rows by columns. Right? You get 3 rows by 4 columns. So the 3 by 4. This one. Rows by columns. That's 3 rows. Rows are the horizontal data. 3 of them. Columns are the vertical data. 4 of them. All right. Next one. So here we have 2 matrices. It says, what is the order of the matrix product XY? It's the same thing I told you. What's the matrix? What's the order of the, if X is this and Y is that? What's the order of the resulting matrix? XY. What's the resulting order? Okay, Jordan, put on some paper on the man and see what it is. Right? Huh? 2 by 2. So this one is a 2 by 3, don't you? And this one is a 3 by 2, don't it? So it's possible because they're equal. The result is this. Two by 2. Next one. Those 2 matrices, which are these answers is the product, AB. Come work it out and tell me. Listen again, guys. Be smart. You don't have to work out all the values. Use a process of elimination. You don't have to work out all the values. You don't have to work out all the values to know which one it is. So for example, you work out the first value and it's 9, you know, so one of them 2 there. Because those are all 2, the first value is 9. Get me? You don't have to work out all the values. All right? And if you work out the first value and it's -6, then I must have 1. If you work out the first value and it's -2, then I must have 1. Chances are it's one of these 2. All right? Chances are it's one of those 2. This or this. So based on in those 2, I would have maybe worked out a second value first, and that's what I get. No, that not right. I've worked out a second value, it could be this. So anyway, go on. Work out until you need at least 2 values. What again? A again. But yes, Jordan, do your work, man. And stop steer. Can't learn by looking at my boss. Don't want to multiply them. So multiplying the rows of the first matrix by the columns of the second matrix. You get the resulting matrix with a 2 by 2, right? First value up here is this row times this column. That first value. So it is 1 times 3. Then 3 times 2. That's first element times first element. Second element times second element. Third element times third element. 3 times 2 is 6. Then -3 times 0 is 0. 3 plus 6 plus 0. All right, so that is a 9. So since that is a 9, you don't say it's either this or this. All right. So I need to work out another value now. You don't make them work this out, because it's a waste of time. I told them a 9. I don't make them work this out either. So the deciding factor really is the second value here. These 2 have to work out to decide which one it is. All right. So let's work out and see which one again. So I'm going to multiply, work out this value now. Second value up here, so. which is the product of this row and this column. That's first element times first element, which is 0. Second element times second element, which is 3. Third element times third element, which is negative 15. And this works out to be 9. This works out to be negative 12. I don't need to go any further than that. 9 negative 12 in the first answer. So this has to be the first answer. 9 negative 12. That is it. Next question. Similar, do this one for me. Kick off fast. A is what is 3A? Can I get? You basically multiply all of us on this by 3, right? So A, 3 times this is 3. 3 times 3 is 9. 3 times minus 3 is negative 9. 3 times 3 is 9 again. 3 times 5 is 16 years. This is the answer. Down here. So the inverse of that matrix is what? Come on. Inverse. Work it out. Which one of them is the inverse? 1 over the determinant times the adjoint. Come on. The inverse. 1 over the determinant times the adjoint. Inverse of a matrix is 1 over the determinant multiplied by the adjoint. Hmm? What the hell you get A? Determinant are not even 17. Hey, I get me upset, you know. I want to get them something around. Huh? Determinant are not even 17. Determinant of this product minus this product minus not plus 1 over the determinant of A times the adjoint of A. One make them like to learn nothing in the class here with them stupid answer there. I can't get them simple thing around in an exam, man, in a sense. Them some are too easy. Inverse. This product is 8 minus this product is 7. 4 that turns 17. And then I come out the exam so easy. Because CSEC chicken up with the wrong answer with them don't have to put on the paper. 4 that turns 17. All the 17 come out now this. Where 17 come from? Seriously, I want to know where 17 come from. Huh? Huh? Where 17 come from? Because them two that him add to 17 is the next thing. Let him add to 17. If you answer the day with 1 over 15, could understand. Say add them. Who will get 17? Where 17 come from? Or 17 come into it? Or 17 come into it? Huh? What you do if you say 17? Huh? No, I'm serious. So I know we get 17 from. Because sometimes teacher have to understand the mistake of people making now. So we can correct it. Okay, I might be doing something fundamentally wrong. Someone know what did you do to figure out it's 17? Huh? Where? You said this is the answer. You see the big one over 17 right also? You know the answer? Negative one, okay, sir? But this here find the inverse of. And this here find the inverse of this. We're still going to work because it's still not add to the thing there to 17. If you thought this was a negative one, then it would be plus, right? But it's a 15. Someone over 17 come into this. Man, can't do the answer there. So I'm not going to exam or you the stuff. Yeah, look here. There's certain things that just don't get wrong in the exam. Inverse. This equal, I'm going to talk about 1 over the determinant. This determinant is this product, which is 8, minus this product, which is 7. So this becomes a 1. 8 minus 7 is 1. They multiply that by the adjoint. Interchange these two. Switch them around. So you get the 4 up here, so, and the 2 down here, so. Leave these two where they are and change the sign. This become a negative 1. This become a negative 7. And this another says a 1. So because this is a 1, final answer is just this matrix. 4 minus 1, negative 7, 2. Yes. That's right. Now, 4 minus 1. This one is the answer. 4 minus 1, negative 7, 2. Come on, man. You can't give them answer, man. Too easy. Yes or no? What time is it? Not even 1 o'clock. This one up here, sir. Come on. What is the order of matrix Q? What's matrix Q in this lesson? 3 by 4. 3 rows. 1, 2, 3, 4 columns. 3 by 4. Answer is this one. What else now? Determinant of P. This is P. Determinant of that matrix P. What is it equal to? Huh? This product is 8 times 5 minus 7 times 6, don't it? 40 minus 42, negative 2. Good? This product, 8 times 5 minus this product, 7 times 6. Done. Next one. What is X and what is Y? Look here. Work it out and tell me again. What is X and what is Y? What is X and what is Y? Huh? D. Yeah, because this times are 5x, right? And this times are 40, right? So 5x equals 40. And divide by 8 to get x equals 8. And this is the only one with an x equals 8, don't it? Now if we waste time, I work out the y. So it has to be this is the answer. Good? Now when we finish the exam, I come back and try that and see if we get 716 when the exam done. We don't know Yeah, but no, we don't have that is the answer. When the exam done, I'm checking back through. I will check and see if the y is actually 16 to 2, just to make sure in case I make a mistake. All right, but for now, that will be it. Matrix is done. Time for vectors. And vectors are another short topic. There were 2 or 3 pages. See there? 3 pages. Vector, let's go. Right away. P and Q are those 2 vectors. What is minus P minus 2Q? Vectors and matrices similar at the time. There are some matrices, some vectors question have almost like as matrices. What is minus P and minus 2Q? See P and Q here, so easy. Let's have some simple calculations. Come on. One again. Work it out. You want to look at it. Work it out, my boss, and stop look. One again. Yeah, maybe. Minus P means minus this, right? Minus 2 times Q means minus 2 times this, right? That's what we're working on. This right here says minus 3 minus 2. And then this is minus 2 times minus 1 becomes a 2. This time this is negative 8. This and this is negative 1. The only answer with a negative 1 is this. So this has to be the answer. Let's just check this as well. Minus 2 and minus 8 is negative 10. That is it. Because all the x values is different, just work out the x value or the first value. And get the answer that way. Next one. Similar question. Teacher. P is this, Q is this. That is P minus Q over here. Same question they give on a different exam paper. And then ask for P minus 2Q. So you can swatch if you know what they're doing. So work out these two for me. For these same 2 vectors. This is 2 different exam papers that set these on. Work out the P minus Q. You get 7 minus 5. Yeah. First one is this, right? Good. Second one over here now, P minus 2Q. So this one becomes 3, 7 minus 2 times this becomes negative 4, 10. Huh? Can be. Minus a negative 4. It has to be a plus 7. Exactly. Teacher, it's a P minus 2Q. 2 times this is subtracted. Answer is this. You understand that? Another one here. Forget the one I write now for P minus 2Q again. Different values. Huh? D. All right. P, which is this one, minus 2 times this one. 2 times this is negative 2, 8. Minus is a plus. 5 minus it is negative 6. 5 minus doesn't do. That's it. Very good. This one down here now. They give us that parallelogram. R is the midpoint up here, so the parallelogram. And so which of these is the correct answer now? ZR is which one of these? ZR. Which of these is ZR? In other words, how do you go from Z to R? And then which of these answers is it correct? Now, we have to remember about this, that this vector over here is the same as this, and this vector down here is the same as this. Or this way is the same as that, right? And this is half of this, right? All right, talk to me now. Go on. Yeah? BSA? No, I work it out. So this vector is double, if you notice though, answers are expressed in terms of double X and double Z, right? So we have to realize that this is double Z and this is double X, right? So this is also double X. And then this now, this is half of double X, half of this double Z, sorry. And this is also half of double Z. And question wants us to go from Z to R. So coming up here with this vector, and then we're going back here. We go from this to this. So it's double X, and then why is it minus half of double Z? So we're going in the opposite direction. So double X minus half of double Z, which is this is answer. Simple as that. All right. Next one. Another one here, similar. This one for me. This time I put some letters on it. So the parallelogram again. So that this vector is U. So we say this vector is also U down here, automatically. This vector coming down is V, so this vector coming down is also V. And so the R can divide it into half V, half V. It's a double R is expressed in terms of U and V, double R. W R, easy. What that one equal to? U minus RV. So V is coming down here. So V is coming down here. Right? So this is a half V down. We'll come in here with a U. We go from this to this. We're gonna come here, so with a U, same as that. And then we're gonna do this half V up here, but we're gonna go opposite direction. So minus half V. So it's U minus half V. Is the answer, right? Is the answer. Another similar question down here. What is BEG? E to G. Parallelogram again. Parallelogram again. And they have parallel sides. Then this vector is K, this vector is M. Huh? I want EG. K plus M, yeah. So this is the M over here, so as well, right? So coming over here, and then go down there, so K plus M, beautiful. K plus M. All right, next one up here. And this question, QP is A, as you can see. QR is B, as you can see. Question says PL expressed in terms of A and B. So PL, it was this vector right here. So we don't want to find the whole thing first, and then PL is just half of that. Huh? A say? Huh? That look right. Half A plus B. What's the whole B? Oh, half of A plus B. Yeah. A plus B. So says A plus B. Okay, look. P R is actually minus A plus B, you know. And this is half of it. See that? Look at it again. The question is asking us for PL, right? Which is half of this vector. PL is right here. And that is half of this whole vector from P to R. But what is P to R? P to R is minus A. Why is it minus A? Can I go in the opposite direction? Plus B, minus A plus B. So PR is minus A plus B right now. All right? And then PL is half of PR. So the PL that I want is half of this. So it's half of minus A plus B. Those that they have minus A plus B. Oh, that is the answer. So the answer is this one. Put over 2. Because minus A plus B is same as B minus A. Want to go to that? Yeah? All right. From this one coming on. Similar question. They want LN. What did they give you? They give you OR is this. OR is this vector. And OM out here is this vector. And then they want us to find LM. That's from here to here. Why not? Do it and let me see. Huh? Yeah, see it? Minor. That's a minor. R is the midpoint of this side, right? I'm going to zoom up and hide that information. Those are the vectors. This is the midpoint of this line. So we're working on LN. First thing I want to do is put the vectors on the diagram. So you can see where we are going. Ready? Ready? So the OR is this, right? That's this. So it means the OL is 2 times this, don't it? That's all. So I can write it down here. So OL is 2 times OR. So it becomes 6A minus 4B. Because it's 2 times that. And then now OM is this. And I want LM. So LM, sit down here. So. And that's a Boltzmann vector of L and the Boltzmann vector of M. We know the both of them. So it becomes OM minus OL. O times the last minus O times the first. The OM is this one. 2A plus 3B. Minus OL is this. 6A minus 4B. Equals. That's 2A minus 6A. That's a negative 4A. The only one a negative 4A in it is this. That has to be the answer. But let's go to the B part now. It's minus makes a plus 4B. So it's 3B plus 4B is 7B. That's why this is the answer. 7B minus 4A. This is same as 7B minus 4A. That is the answer right there. All right. More question. This one up here. Everything that's up here is on the diagram. O element of triangle. R is the midpoint of this side. The vector from here to here is A. It means the obvious is also A. And then the vector from here to here is B. It's the midpoint as well. So this side also is B. And the question wanted to simplify RM. RM, too easy. RM. Easy, too easy. What is RM equal to? Huh? RM. Only again? To go from R to M, we're just gonna come back down here so with the minus A, don't it? And then go 2B out here, so don't it? So it's minus A plus 2B, same as 2B minus A. Is the answer. All right. I finished with the vectors. No, one more down here. So, oh, another question. I want LM. So here they wanted RM in this question for the same diagram. But down here now they want LM on the same diagram. LM. So LM. That even easier. That is minus 2A plus 2B. It's minus 2A plus 2B. This one. Which becomes that really. So this is the answer. And the vector's done. All right, 116. I want to finish 2 o'clock. Let me see now which topic we can do next time. We have measurements. I don't want the measurements. Measurements is a lengthy topic. So much page of it we have? Measurements are a lengthy topic. Statistics also is a lengthy topic. A lot of statistics questions we are going to see. A lot. I want to finish something we can finish quickly. Relations and functions. Suppose we can finish this now. Yep. No. No. Relation and function lengthy too. Geometry and tricks. Let me see this. Man, what a holy Pakistan. All right, it's now 1:17. What do we do? Start and go and finish 2 o'clock. What do we do? Start another topic? We're not going to finish it though. Huh? Now what test tomorrow? Which test you have tomorrow? You have the test tomorrow, Joe? Huh? I don't have any tomorrow. All right. The topic we can maybe finish quickly is the functions, you know. I think we can finish the functions quickly. Within an hour. I finish. Yeah, we can finish the functions quickly. I could do the functions. I could do the functions. Come, let's go straight into it. Let's do the functions. Let's go straight into the function and we'll finish at 2 o'clock. 45 minutes, 40 minutes. 40 minutes. Let us run through the function. Must have finish it in 40 minutes. All right? So we're going to use the topic function. See, first one there, give me that y varies directly as x. And y equals 19 when x is 152, which are the following equations represent the relationship. Direct variation. Y varies directly as x means that y is equal to k times x. Y is equal to k times x. And I give you now the pair of values for you to find the y, right? So, y equals 19, x equals 152. You put them in there, right? So it means that 19 is equal to k times 152. So you divide by 152, you get the k equals 19 over 152. All right, that is what, 1 over 8? So know that the k is that. Did you go to 1 over 8? Check that for me. What is your work out to? Not this enough, k and 8. And can't be the cedar. I must say the answer. So the k equals 1 over 8, right? It's a 1 over 8. Can check it now. 8 times 19. 72. Yeah, man, 152. So the k is 1 over 8. So since the k is 1 over 8, this equation becomes y equals 1 over 8 times x. That's why that is the answer. So my question is not work out. At all them is all about looking and knowing the answers. This one next. The distance L of an elastic string is stretched by hanging an object of mass M varies directly as a mass. If 5 kilograms stretches the string by 31 centimeters, how far will 29 kilograms stretch the string? That's a direct variation question again. Just have to work it out. Right? Just have to work it out. Let's go again. The distance L of an elastic string. The distance L that an elastic string is stretching by an object of mass M varies directly as the mass. So we say L is equal to a constant times the mass. Here's basically when the mass is 5, the extension is 31. When M equals 5, when M equals 5, the L equals 31. So put in M in here to find K. So it means that 31 is equal to K times 5. But divide by the 5, when the K equals 31 over 5. And the question is asking now, no. So this formula becomes that the length is now equal to 31 over 5 times the mass. Just asking you, when you put a mass of 29 on the string, put in 29 here, what is the length? Right? How far will it stretch? That's the L you're trying to find, the L. So put the 29 here now. So when M equals 29, the length becomes 31 over 5 times 29. That we could question with them numbers. All right, just almost 900, don't it? That's all? 31 times 29, almost 900. See, almost 30 times 30, don't it? You're estimating. 900 over 5 is how much? 900 over 5 is how much? $900 over 5 is how much? Huh? What are wicked numbers you give, man? 18. You can't divide 900 by 5. Eh? 180. So the closest answer to it is this. So this must be the answer. But this, I'm not, in the exam, I always time I work that out. These answers, you can estimate it. 31 times 29. It's close enough to 30 times 30. It's 900 over 5. And then we just work out 9 over 5 as my estimate. Right here. Approximately 900 over 5. All right, next one. It says, given that y varies inversely as x, y is 16 when x is a half, which of the following equation represents the relationship between them? I don't want to hear now. Well, I think so. Let's make sure. No, this one. Because it's inverse. See here, y is equal to k over x. So multiply of the x, it means that xy is equal to the k. So it's when the x is, when the y is 16, the x is a half. It means that the k is equal to half of 16, which is 8. It means that this equation here, so, which is what the equation is going to be, it becomes y equals 8 over x. to the last one. That is inverse. That is it. The direct inverse variation question. Next one. Next one says, the point where the linear function crosses the horizontal axis is what? Point where the linear function crosses the horizontal axis. Which one are these? Horizontal axis. Which one of these is the horizontal axis intercept? Which one of them? Huh? Where crosses the horizontal axis? Horizontal axis. B, the horizontal axis is the x-axis, so this is it. X-axis intercept. The point where the linear function crosses the vertical axis is the what? Huh? The y-axis intercept. This one, the y-intercept, it crosses the y-axis and the y-intercept. Next one. The equation of a line, we pass through this point at a gradient of 4. We pass through this point, that's a point on the y-axis, it means that the C equals 5. And this is the gradient, this is your M. So the answer is which one? C, y equals mx plus c. Y is equal to mx plus c. That is it. Next one. That line L is parallel to this. What's the gradient of line L? If you get a gradient out of this equation, what's the gradient of that line? How can I get a gradient from this line? By putting it in the form y equals mx plus c. Make y the subject. And then the value here is the gradient. What's a young set of? I'm not sure what the word class. What's up there? What's on the side? Yeah. JC, wake up, man. Wake up. You know everything in the exam, you go sleep? Huh? You know everything in the exam Friday, you go sleep? I go work. Work. Come now, we make y the subject of this equation. Simple. Take the negative and bring it over here, so. You get 3x minus 9 equals 7y. Now divide by the 7 there. So you get 3 over 7, x minus 9 over 7 equals y. Y equals mx plus c. The gradient is this one. That's a m. 3 over 7. Y by itself as a subject. But up on the left side or the right side, don't matter. Mx plus c. Next one. This one for me then, another one. Line L is parallel to that. What's the gradient of L? So do that one for yourself. Pick up fast. Most can look at it and know the gradient. Similar. What's going to be the gradient of this one? Hello, mom. Stop tick-tock and do your question there. Hey, we're doing something on the year and next time I want to rule up on the registration form. No phone in my class. Who know me learn that half of this year? One of the worst ever. I'm addicted. That's why I said no phone in my class next year. I rule me up on the registration form. No phone allowed. Yeah. Come, yeah, me have one box. Put the phone in there, write the name, put the phone in the box. Yes. You're not going to hear it. You're going to hear it. Come now. What's the answer for this one? Phones will be confiscated during the class. Place in a box. The name on it. When class done, you get the phone. And go over everything. Come on, answer for this one. Take so long. Huh? See, yeah, man, you over the 5y over here, so you get 2x minus 8 equal 5y. Then divide by this 5. 2 over 5x minus 8 over 5 equal to y. Huh? Parallel of same gradient. Parallel of the same gradient. Them say perpendicular. If them change this to perpendicular in the exam, they will flip this and change the sign. And put negative, this will be this. Negative 5 over 2, but them say parallel. So this one is the answer. Them say perpendicular or flip it and change the sign because them parallel. Parallel lines have the same gradient. So one here now, speak of the devil appears. Perpendicular now. And then give me the line. The same line again, no? Almost. What is the gradient of that? What's the gradient of the line? Flip this and change the sign. Don't it? So the m equals 2 over 5. So the perpendicular gradient is negative reciprocal. Perpendicular gradient is minus 1 over the parallel gradient, that gradient. Flip and change the sign become minus 2 over 5. Next one. Same thing, what will this one be? What will be the perpendicular gradient to this one? Minus 7 over 3. What will be the perpendicular gradient to that one? Minus 7 over 3. Minus 7 over 3. This one. The dark in what is minus 7 over 3. This is the answer. If this was y equals 3 over 7x minus 9. That will be the gradient, minus 7 over 3. Flip one at the other and change the sign. Next one up here. Same thing again. The gradient of this line is what? What's the gradient of that line? So answer them here. What's the gradient of this line? Answer that somewhere. What's the gradient of this line? Huh? What's the gradient of this line? 3 over 2. If you divide by the 2 and make y alone the subject. So it becomes y equal minus 3 over 2x minus 4. The mass of the y-axis intercept, it will be 0, negative 4, negative 4. So it's minus 3 over 2. This is the gradient. Next one. What's the y-intercept now of this line? See, the same thing, you know? On a different exam, you know. So this question asks for gradient. This one asks for y-intercept. See it? On a different exam paper. So you know, SWOT answers. They might think it's the same question they're asking. This one asks for y-axis intercept. What is it? The negative 4, the same equation. Negative 4. See that? Different exam that here. CSEC, 2 different exam that. So, see what that about. This one. This one asks us where the line cut the y-axis. I've seen questions that ask where this cut the x-axis as well. The same graph. Where does it cut the y-axis? Right here is what? What's going at that point? 0, negative 2. The point. 0 is the x value, negative 2 is the y value. You come back on the 4th. Zero, negative 2. You start about 4 and then go back on the 4. Somebody call you addicted, they prove say you're right. They're right. Prove say they're wrong. Can't prove say they're right. Let's go. Next one. This line. Gradient of this line and this graph is what? What gradient of that line? Just count the rise and count the run. Come on, easy stuff. Rise over run. Rise over run is the gradient. How much is the rise? 2 is the rise. What's the run? 4. See, rise is 2, run is 4. See, 4 units out there. So that's 2 over 4, which is a half. Positive half. See that? Positive half. Count the rise and count the run. Next one. Which of the following pair of lines are perpendicular? We're going to know them perpendicular. The perpendicular when the product of the gradients is -1. That's when they're perpendicular. You multiply the gradients and you get -1. They are perpendicular. They are parallel, the gradient is the same. Talk to me. What's the gradient of these two now? This gradient, if you divide by the 2, you get -3/2. And this gradient, you're going to get 3/2, don't it? See that? I take that 2x, 2y, and bring it over here and divide by the 2, and get 3/2. That now equal -1, right? These two now. Them two are parallel, don't it? Two gradients are the same, no sir? Them two are parallel, no sir? Parallel. What about this one? Gradient of this one is -4. Gradient of this one is a quarter. Is it this enough? This one is -4, is this gradient. And we divide by the 4 here, and get a quarter times a quarter. That equals -1. So yes, that is it. These are the two perpendicular lines. Try this one. Gradient of this one is 3/5. Divide by the 5. You get 3/5. No, -3/5. I'll carry it over first. This one will -3/5. -3/5. And this gradient would be half. That will equal -1. So you see the answer where the product of the gradient is -1. All right. Next one. Which of the following represent a straight line equation? Which of these is a straight line equation? Pick up fast. Straight line equation, which one? A, B, C, or D is a straight line equation. Okay, I'll upon this and tell me at a glance which one is a straight line equation. This can't be a straight line equation because it have a square in it. You see a quadratic that. Listen. A curve, I tell you now, of the products and quotients of x and y. Curve has the products and quotients of x. That's a product of x and y, not a curve, not a line. The one that can be in form y equals mx plus c is the line one. See it right there, so. Here over the 3 here, y equals mx plus c. This one cannot be a curve, see the square there. See the square there, and product of x and y. Those three cannot be lines. They are curves. This is the line. Can be written in form y equals mx plus c. Which of the following represent a line again? It's another example here. Which one? This one. Which relation is this? Relationship best describe this mapping as well. Which mapping is this? Many to one. Many to one. See there? Many mapping to one. Many to one. Many to one. This one. H of x is that, which is h of -6. We're going to work out h of -6. Plug the -6 in there for the x. One again. 3 times -6 minus 2 over 5. -18 and -2 is -20. Over 5. -4. Same thing down here, so h of 4 as well. See, same function, you know. But it's now h of 4. Huh? Plug 4 up there, so you get 3 times 4 minus 2 over 5. That's 2. All right? 12 minus 2 is 10. 10 over 5 is 2. Next one up here. Another one. G of 6. G of -6 is what? What answer? Yeah, this is 40 minus 3. What you get? Negative 9 is the answer. Because it becomes 7 times negative 6 minus 3 over 5 become negative 42 minus 3 over 5, which is negative 45 over 5, which is negative 9. That is it. Next one. Particular function. Which of the following best describes this function? Look at it. Which of these represent this function? This all of these are 3 more than that. X plus 3. All of those values are 3 more than the x value. I got x plus 3. This one down here. What is f to the minus 1 of 1 if f is this? This is the same as saying f of x equals 5 minus 2x. You want f of minus 1. F to the minus 1 of 1, you want. You know, some of you nothing from the people I'm online all day. Ocean, you okay? Ocean? Luke?
Yes, sir.
Oh, I wonder if you got, I don't hear a word out of none of you today. You know good?
Yes, sir.
Okay. Come here, solving this one. F to the minus 1 of 1, you want. 2 again. So I mean, say f of 2 is 1. Yeah, it's right. F of 2 is 1. Because look, if f to the minus 1 of, look, you can solve this quick. You can say, right, f to the minus 1 of 1 equal a number. So 1 equals f of that number. So 1 equals 5 minus 2 times the number. So solving this, so you get 2n equals 5 minus 1, which is 4. So n equals 2. Yes, 2 is the answer. Whichever way you want to do it, that's fine. We'll find the inverse function first and then put in the one same difference. This one, which of these is a function? Which of these is a function over here? Which of these is a function? Which is a function? Which of these mapping is a function?
G.
Huh? Ah, shit, that hurt me. Look here. For a mapping to be a function, you can only have one mapping from each element in the domain. One and only one mapping. Additionally, you cannot have any free element in the domain mapping. Well, no, years, you cannot have any, look, this one is not a function because it have two mapping coming off it. Additionally, this one in the domain don't have no mapping coming off it. So those two spoil this one as a function. This and those two makes that not a function. For it to be a function, each element in the domain must map, and when they must map one time. Don't come class and pay attention and listen. We go through 1 million of these. And at this stage, them something still are going to problem. Now joke, man. Come class every day and smile and happy and simple basic thing like this, and I don't know. I'm not going to go through them stuff. I remember one class to come full out the board with them and go through much of them and explain and all of that. You cannot forget what you learn. And you retain what you learn by practicing and revising and reviewing. This one is not a function because this one mapping twice. This one is not a function because this one mapping 3 times this now map and this now map. So 3 of them spoil it in that one. This one is a function because each one of them map and they map 1 time. So this one is a function. So I'm after them session, I don't know, because we're not going to exam we write foolishness. And these are things that we have gone through multiple times. I want to see them something about how much past paper want to come out. So I get 58, get this, we get that, we get how much I want to get. So when I get them wrong now. When I get them wrong now, I'm going to tell me go on paper. I'm going to get 58, sir. I'm going to get 57, sir. I said, do what I want when you get wrong. Come to me if you don't understand. No, come with none. And they're not have a foolish response. And they're upon almost every multiple choice paper. Almost every multiple choice paper have one of these. So when you get 58 and 59 and 60 all the time, but come and get 60, sir. Get 58, sir. Get 59, sir. Lie not tell. But nobody tell me the right answer a while ago. I'm not getting upset, man. This one. Set up ordered pairs. Which of them, when added to the set, would form a relation that is not a function. All right. So they give you these ordered pairs. Which one of these, if you add to the function, it is no longer a function? Which of them here? If you add to it, it is no longer a function. Which of them is going to, in other words, which of them is going to cause it to have one value map into 2 different values? That's what it is. That's how it fails as a function. If you put in one of these pairs, and it's such that you have an x value that is mapping to 2 different y values, then it is no longer a function. So which of these pairs will do that if you put them in, add it to that? Which of them will do it? Which of these pairs will fail this pair, that set? Cause it not to no longer be a function. That's what it's basically saying. Look, which of the following points, when added to this set, would form a relation that is not a function? Which of these pairs of values will do that? Which one? Which one we just tell a while ago? You can't have this. You can't have one x value mapping to 2 different y values. So which one of them pair, if you add it over there, so it will cause this? Which one of them? You can't have this. You can't have one x value mapping to 2 different y values, x and y. You cannot have that. You cannot have this. You cannot have that. So which of these pairs of values, if I add it to this pair, this set that I have already, is going to create this situation that you don't want. That is what will cause it to no longer be a function. Those ordered pairs to no longer be a function. What is it? Which one of them? But I feel to talk now. Online, somebody answer. Somebody answer online. Because they may not answer. Online, somebody answer. Which one of these, if I add it to the function, will cause it not to be a function anymore? Which one of these pairs? Which one?
A.
Which one of them? Huh?
A.
Thank you very much, Luke. When I come class?
Come to this day.
It must be A, because A have 2 in it, and this have 2 in it. So 2 I'm up to 7 already up here. So if you put in that one and then the 2 I'm up to 8, you can't have that. What look like it? What look like it? This like it? So everybody get that like it. Talk about that in this class. Do your classes to another like So you can't add this one. You cannot add this one to it. You cannot add this one to it. Because if you add that one to it, you already have 2 mapping to 7. And if you add this one to it, you're now going to have 2 mapping to 8. And you cannot have that. That becomes a one to many. That's why you cannot add that one to. All others will work. All the other points, if you add them to it, you still get your 1 mapping to 1. A different value. But you cannot put in the 2, 8 in there. You already have 2 mapping to 7. You cannot put 2, 8 in there, because then you will know have 2 mapping to 8. They'd have 1 too many. Get me? Same thing over here, so. See there? Them have these points and them have the same thing now. Same points and them have. Which one of these will cause, if you add it to this set of values, will cause it to no longer be a function? Which one? See, you know, learn something now. What you must do is when you learn it and retain it. That's no problem. As I always say, if you don't know something and then you learn it, you go back home and you do it over. Because I don't want to do it and me do it. You learn it when you do it. So if it's me bear it and explain it or whatever, you don't do it yet. You have not done it as yet. So you go home and you really do it. Do it over by yourself and you meds it. When you learn it now, when you go outside and eat food on the pan down, play ball, come back, I have the same person can't do it again. Not joke. Joking. No one kill like exam, yeah. You know, I'm managing that. No. Serious. I understand done paper 2 already. I want to do paper 2. Stop smile, man. Next one. Which of the following points lie on this graph? Which one of these points lie on this graph? Easy. Which point lie on the graph? Which of these points lie on that graph? What are you going to know? Eh? D, you say? Good. Because you plug the 0 in there, you're going to get the -3. Thanks. D. So all you have to do, plug in like the 2 and see if you get the Y value. I plug the 2 in there right now. Would the Y value come out to 3? No, because I plug 2 in there. I get 2 times 3 is 6. But something wrong. Huh? He said, which of the 4? Now the X value, that's 4. That become 4, right? That become 2 times 2 minus 3 would be 1. But the Y value says 3. See that? So you can't work. You get me? That's what you have to do. So the last one, the last one actually the y-axis intercept. That's what it is. Next one. F of -3 is what? Plug the -3 in there. What you get? What I work out to? You can fast. Huh? What the answer? Get covered. What the answer? C is the answer. C. If I plug this in there, you're gonna get 2 times -3 squared minus 1. -3 squared is 9. 9 2 is 18 minus 1, that is 17. Next one. This one refer to that mapping. How do I go about describe what relation? Look at it carefully. These values map onto these values. Which of these relation is true? Just eliminate. Y is less than X. Is that true? No. All of them, the Y greater than X, right? So this one is not true. Next one, Y is a factor of X. Is that true? Y is a factor of X. X are the factors. So this is not true. The Y's are multiples. X is a factor of Y. X is a multiple of Y. No, this one not true either. So you see the answer. X is a factor of Y. This is it. They could have also said Y is a multiple of X, don't it? See that? That's the correct answer. This one, almost the same thing they're asking in this one. But the switch it on, look. See it? The switch it on. Switch on the order of the mapping. See? See, let's switch it around. The same question now. A lot of people want to see that thing is the same question now. It actually changed. But this was the range up here, so it is now the domain in this one. You see that? See? So do not go in there and swat answers. Ready? Our diagram is which one now? Y is more than X. This is not true. Next one, Y is a multiple of X. Also not true. X is a factor of Y. That also is not true. X is a multiple of Y. That one is true. So question like this, they use elimination, eh? You can check. All right, this one no. Fine. Eh? This one, which are the following graphs? Which are the following line graph represent this inequality? Which are them? Which one? You start at -2, you end at 4. This means that you don't want a -2, so you put that unshaded circle on a -2. This means that you're including the 4, so put a shaded circle on the 4. So it's from -2 to 4. This is it. Not including -2, including the 4. Good? Next one. It's another one here. What does this one represent? There's no shaded circle on the one right there. And you're going to the left. Meaning what? Which one of them is correct? This, or this. Which one? Just less than one alone. A. If this was shaded, then the answer will be this one, not it? Good. But it's not shaded. So this is the answer right here. Next one. This one says, they give us a quadratic. It says the maximum point is, where the maximum point? It's the maximum point up here, or the coordinates are that maximum point up here. So what is that? What is that maximum point? 2, 4. Last answer, 2, 4. D as in dog. The equation of the axis of symmetry of this line, of this graph is what? Axis of symmetry is a vertical line, guys. It's a vertical line like this. Axis of symmetry is a vertical line. And vertical lines have an equation, x equals a number. So it's x equals 2. X equals 2. See that? Y equals. Vertical lines is x equals. Axis of symmetry is always x equals. So it's this one. Most people come out that one and come to the exam, shut it up, kill it. I think they get it right. And put the wrong answer. X equals 2. Vertical line, axis of symmetry is always x equals the xc value. It's for the turning point. Enough, enough plenty work for doing, an exam, enough plenty work for the serious. You guys have a lot of work you have to do. A good, hey, I'm send a bank of question and work more back in for myself, you know. I was sending the them question, but I don't do pass over. I'll do them question. Let them up. Get me? That does so much fast people and still can't get them all right. Next one. The value of x at the point where the graph got the intersect y equals 0. Now, what is y equals 0? Y equals 0 is which line? The value of x where the graph intersect y equals 0. Y equals 0 is which line? Which line is y equals 0? Y equals 0 is the x-axis. This question is asking where the graph got the x-axis. See it here? Got the x-axis here, so, and here, so. What are the x-values at those 2 points? What are the x-values at those 2 points? You got the x-axis here, so, this and this one. 0 and 4. X equals 0, x equals 4. The first one. Next one. The value of x will cut now the x-axis. Same question, you know, but this time, see this one exam paper, them say x-axis. Another exam paper, them say y equals 0. See that? A different exam paper, this come and find. They should have the same thing in a different way. Same thing. All right. Next one. Which are the following represent the equation of Australia? I did this earlier. Trying to be straight line. We did this earlier, right? This one, right? Straight line. Up here, so now. Which of the following represents a function with this as a domain? This is a domain now, where x is a member of this. Which are them? And so it is x squared plus 3. Which are these pairs? It's for that function. Simple, guys, just plug in the x values and see the match the y value. It's a process of elimination. So what me now? If I were you, I wouldn't bother with this value, with the 0. Because all of them is the same. Before one that is different. So I would maybe try this. X equal 1 first. So plug in the 1 in here so first, we're going to get. We're going to get 4, don't it? So this is going to give you a 4, right? So plug in the 1. You're going to get 1 squared plus 3, which is equal to 4. So based on that, is either this or this, don't it? So I can eliminate this one and eliminate this one, right? Then I'm looking over here, so now is either this or this now. So I can try the 2. That's all. Let me get 5, this is the right, let me get 7, then it drops. So I'm going to try 2. So let's try the 2. 2 becomes 2 squared plus 3, which is 7. So the one with the 7. So this is also wrong. So the answer is the last one down here. You have to do any more. See that? Good. Next one. This function is x cubed now. For that domain, which are these match x cubed? Which one? D, because the negative 2 cube is negative 8, don't it? There's one with the negative 8 in it, so it is D. Because negative 2 cube is negative 8. So look out for that, right? This one gave you now minus x squared. Careful. Minus x squared. Minus x squared. Which of them is the right answer? Which of these is the correct pairing? Which of them is the correct pairing? Minus x squared. Minus x squared, you're putting in. So that, for example, if negative 2 to a minus negative 2 squared, that's going to become negative 4. See that? And put in negative 1, it's going to be minus negative 1 squared. That's going to become negative 1. See that? Put in the 0, you're going to get 0, don't it? You put in the 1, you're going to get minus 1 squared, which is still negative 1, don't it? And if you put in 2 now, it will be minus 2 squared, which is still negative 4. So you notice from these, the only values are 0, negative 1, and negative 4. See that? So it's this one. We're going to put that one and get it wrong. Look, the minus is not squaring, guys. Only squaring the x. See that? The values must come out to be 0 or negative. All right, so that is it. So careful that question like that one. Careful. All right. So that's your age. Next one. Which of the following represent a function? Which of these represent a function? A linear function also. Linear function. Which of them is a linear function? Which of them is a linear function? Huh? It can't be this and it can't be this. Because these are curves, don't it? B cannot be a function. B cannot be a function because it's going to feel the vertical line test. Remember, a function, you draw the vertical line on it, you have to put that only 1 point. If you put a vertical line on this, it crosses at an infinite number of points. A graph with a vertical section cannot be a function. Because, for example, let me zoom up on it. It means that you have a point up here. Suppose you have 4. And down it's a negative 4. And let's write this at 2. It means that 2 are mapped to 4 up here, so, and 2 are mapped to negative 4 down there, so. That will be a 1 to many. So a graph that has a vertical section cannot be a function. A graph a shape like this, for example, cannot be a function because it fails what we call the vertical line test. Vertical line cross at 2 points, not a function, not a function. See that? So the question asks for a linear function, but this one is not a function. This one is not a function. It's a line, linear, but not a function. Not a function, not a function. Now, these two are functions, you know. That's a function and that's a function, you know. But what's the problem with them? They are not linear, but they are both functions. So this one is a one-to-one function. I'm going to draw a vertical line on it, it can cross at only 1 point. And it's one-to-one because I put the horizontal line can only cross at 1 point. So this one is a one-to-one function. One-to-one function. But it's a curve, it's not linear. So you can say, but it's not linear. That's why it is not the answer. And then this one also is a function. Because any vertical line I draw will only cross the graph at 1 point. Remember, we also do the V test first before you do the H test. Do the vertical line test before you do the horizontal line test. So this is a function because any vertical line I draw can only cross at 1 point. But then it's a many-to-one because if I draw a horizontal line, you cross at 2 points. Many-to-one, it means that you have two different x values mapping to the same one y value, which is okay. See, two different x values. X value up here, and x value down here. So this might be positive 2 and negative 2. Two of them are mapped to the same y value of, say, 4, which is fine. That's a many-to-one. It's a many-to-one function. So this one is a many-to-one function. The positive graphs are many-to-one functions. Many-to-one function. But problem right that answer because it is not linear. This one is a function. It is one-to-one and it is linear. Why is it a function? Because any vertical line I draw can only cross at 1 point. And it's a one-to-one because any horizontal line I draw can only cross at 1 point. So it's a one-to-one function and it is a line. This down here, as I said, is a one-to-one function as well. But it's not a line. So it's not linear. The question asks us for a linear function. So the function that is a line, that's what you want. So it is this one over here. This one is a linear function. So this is the answer. A linear function is that guy also. This. A linear function. 208, 210. I'm going to stop it now. I'm going to just finish a page here. Sorry. No, we just 2 left. 2 done. Let's finish this thing. Now I'm going to send that paper. I'm going to send that something. I don't know how many times practice. We'll see you for the exam. Look here. You saw me say, no, they need this, they need this. Because them answer not give me for them question. I feel so happy about the paper too right now. And the paper one like it a struggle. What with the paper two? Huh? Let's go. What is the paper one easy and I get the question them wrong? Which of the following graph is a function? Look at it. Which one is a function? You want to borrow my glasses? You want to borrow my glasses? Answer one, answer. Huh? Here's a function. Look at the points. The points are here. This is our point here, so here, so. These are the points on this graph. And this one, you have a point here, so. A point here, so. A point here, so. A point here, so. A point here. So. Those are the points on that one. Down here, you have here, 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 and there. And then this one, you have these horizontal points, and you have these vertical points. Which of them is a function? A, because you can't have in a place where you draw a vertical line across more than once, right? So I draw a vertical line on this, It crosses through here and here, so. So not a function, not a function. We draw a vertical line on this, cross 3 times, here, here, and there. So not a function. And then same thing with this one, I draw a vertical line through here, crosses 4 times. And so it is not a function. As simple as that. And if you stop come class and joke, you know. And if you stop come class and joke, this one now, any vertical line I draw can only intersect 1 time. So this is the function. So the answer is this one, the function. That's a function. 2 more questions. What is the x value at the point of intersection of the system of functions, this and this? What's x value? When they intersect, at the point of intersection, at the intersection, the y values are the same. So this is going to put in them equal at the intersection. What we're going to do? Put this equal that and find the x. You see that? See that? At the point of intersection, the y values are the same. So the y value is 3, that equals 3. So basically solving 5 over 2x plus 1 equals 3. See that? This equals that. At the point of intersection, the y values are the same. Here over this, you get 2. Multiply by 2 and divide by the 5, you get the x equals 4 over 5, which is same as 8 over 10, which is same as 0.8. Answer is 8. So that, next one, last one for today. A parking lot charges $1 plus 25 cents for every hour or part thereof in which a vehicle is parked. The function C of H that represents the parking cost is. So it's $1 plus 0.25 for every hour. So the $1 is a fixed charge. So they're going there, you will pay $1. That's what it basically means. All right, and then now you charge this for every hour. So this is varying with the number of hours that you spend, but the one is a fixed charge. Which of these now represent the formula? Which one of them? Represent the formula to collect the charge for the charge. See. $1 you pay as an enter, and then for every hour you pay 25 cents. These represent the hours. That is it. Guys, no, seriously, we're not forgot to do summary. Not forgot, no need for the summary. Remember, start fretting and worrying. I'm fretting and worrying, especially those youngsters sleeping all the whole time. Sleeping all the whole class. You guys need a lot of work. You guys need a lot of work. All right. So I don't know. Maybe in the evening, tomorrow evening at class, tomorrow I continue the same thing. And if maybe at 3 hours after. So you're going up, you know, you're 3 hours and start making a feel. You don't want to learn nothing, you know? Yeah. I'm not serious. You think 3 hours I learn that time? Here guys, I'm ending it now. Bye. See you tomorrow.